Hi, Math 117. Today we're going over the last section in Chapter 4, Hypothesis Testing for Proportions, okay? In 7.2 and 7.3, we went over hypothesis testing for the mean. Now we're going to do it for proportions. Please remember that p hat, okay, is going to be the statistic. That is something that describes a sample. And the way you calculate p hat is x over n. So the number of successes over n, okay? And p, all right, without the hat, is going to be our parameter. Okay, here we go. Okay, there's one thing you should check here to make sure the population is normally distributed. And you will know that it's normally distributed if you multiply n times p and it's greater than or equal to 5. And also n times q is greater than or equal to 5. Remember, q is just the complement of p, so that's simply 1 minus p. So usually they will be normally distributed, but this is how you would check to see that you can continue on to this one sample z-test for a proportion. All right, well, how do we calculate the z statistic for proportions? Well, we're going to do p hat minus the population proportion, so whatever's in your null and alternative hypothesis, all divided by p times 1 minus p, or we could call that q, divided by n, and we're taking the square root of all of that. Okay, so that's the formula we're going to be using. Just remember, please, that it's your alternative hypothesis that tells what type tail the hypothesis test is. If the alternative has a greater than, we know it's going to be right-tailed. If the alternative hypothesis has a less than inequality symbol, it will be a left-tailed. And then if the alternative hypothesis has a not equal to, it's going to be a two-tailed test. All right, we're going to go through this example first by doing it with the formula, and then I will show you a shortcut on your calculator. Okay, example. Do free samples work? You interview a random sample of 50 adults. The results of the survey show that 48% of the adults say they were more likely to buy a product when there are free samples. At alpha equals 0.05, can you reject the claim that at least 52% of adults are more likely to buy a product when there are free samples? Okay, this right here is going to help me write the null and alternative hypothesis. Okay, so remember, your null always comes first, followed by your alternative. Today, we're writing p here for the population proportion instead of mu. That's what we've been doing in 7.2 and 7.3. And this says at least 52%. Okay, well, that's going to go here because that's greater than or equal to 0.52. Because it has this equal to, that means that it has to be the null hypothesis. So this is my at least sign, okay? And this happens to be the claim. The claim can either be the alternative or the null, depending on the problem. Well, the alternative hypothesis is just opposite of this. So what is opposite of greater than or equal to? It's less than 0.52. Remember that it is your alternative hypothesis, which gives us what type tailed test it is. So this is a left-tailed test because of this less than sign. And we are going to use z. I should have first checked to make sure n times p is greater than or equal to 5 and n times q is greater than or equal to 5. We will just take that as it is, okay, so we can continue with this test. All right, well, I need to get right here to I need to see what my z statistic is. So let's rewrite the formula that was on our other slide. That's p hat minus p, I'm going to put a 0 for the null or the population, all divided by the square root of this, 1 minus p divided by n. So I'm going to plug in my values. P hat is 0.48 minus the population proportion 0.52 all over 0.52 times 1 minus 0.52 divided by n. Oh, and n we already know, we know n is 50. Okay, when I put this into the calculator, out pops the z-statistic of negative 0.566139. So that is this z-statistic here, negative 0.566139. Well, now I need to know my p-value, right? So what is my p-value here? Well, we need to go to a z-score to a probability, and the way you're going to do that is use normal CDF. So if you need a reminder on your calculator, you go to Menu, Probability, Distributions, and then Normal CDF. It asks you 4 questions here. What's the lower bound? What's the upper bound? Okay, what is mu and what is sigma? Well, the lower bound here is just going to be a really low number. So I'm just going to say negative 999,999. Your upper bound is the z statistic we just found, and that's negative 0.566139. Mu is going to be 0, and sigma is going to be 1. When you put this into your calculator, a number will pop out. That's going to be your p-value. And it says your p-value is 0.28565. You're almost finished now because now you just need to be able to draw a conclusion from these numbers. Well, you always want to compare your p-value to alpha. Okay? Alpha here in this problem is 0.05. We just found the p-value to be 0.28565. Looks like the p-value is greater than alpha. Anytime the p-value is greater than alpha, we fail to reject the null. Okay? So you always want to write if you fail to reject the null or you reject the null, but then you want to take it a step further and say, what does that actually mean in the context of the problem? Well, I'm going to say there is not enough evidence, at the 5% level of significance to reject the claim. What was the claim? That at least 52% of adults are more likely to buy a product when there are free samples. There are free samples. So we don't have enough evidence to reject this claim. We're failing to reject it, okay? So basically saying that people, or at least 52% of adults are willing to buy the product when there are free samples. You can do all of this. I mean, you still have to make your conclusion in your head, but you can do all of this with one command on your calculator. The way you're going to do this is you're going to go to Menu, Statistics, Stat Test, and you're going to go to the one proportion z-test. It asks you 4 different things. It asks you, well, what is the population proportion in the null and alternative hypothesis? Okay, well, that was 0.52, okay? And then it asks you X and N, and also this, what way the inequality sign is going for the alternative? Well, we knew it was less than, we knew n was 50, but what the heck is x? Well, we can figure that out easily, because remember, to find p hat, you simply divide x by n, okay? Well, we know p hat was 0.48. We're looking for x, and we know that n is 50. So in order for me to find x, or the number of successes, I would just multiply both sides of this equation by 50. And when I do that, we get 50 times 0.48, and that is 24. So x is 24 here. After you put all of this into your calculator, your z value or your z statistic will pop out, and that's what we did. That's exactly what we got when we used the formula. And then it calculates your p-value for you, and that is what we also got using the formula, okay, or using, I guess, normal CDF. Well, now you can say, okay, well, the p-value is greater than alpha. Remember, alpha was 0.05. So we fail to reject the null, again, meaning that there's not enough evidence at the 5% level of significance to reject the claim that at least 52% of adults are more likely to buy a product when there are free samples.